With that, I will head into our first keynote speaker, second keynote speaker for the conference, first one today. We have Niranjan is going to talk about the developer experience at Google. And I'll hand it over to him. Interesting fact, Niranjan actually interviewed me when I was applying at Google. So don't let that bad decision factor into your evaluation of his keynote. But take it away.
Thank you. All right, how's everybody doing? You all had enough caffeine to last through the day? All right, just making sure. Please give a round of applause to all the organizers. I think they've done a fantastic job with all the logistics and facilities. So, my name is Niranjan. I work at Google on developer products. Particularly, I work on something many of you might have heard of. It's called Firebase. We launched it as a mobile developer platform a few months ago at Google I/O. I specifically focus on a lot of tools and infrastructure that are geared towards app quality. And the thesis of my talk here, my keynote here today, is how we've actually demonstrated that by investing in developer experience, you can have a positive impact on app quality and quality of your software and code base in general. I'm going to speak mostly about mobile, but a lot of the things and the lessons that we've learned are fairly generic, and you could potentially apply them to other areas as well. I think towards the end of last keynote yesterday by Mansi, you probably saw some of the challenges with the wide variety of Android devices and the large diversity in devices that's actually making it challenging to be a mobile app developer. People out here who've actually built and tested mobile apps can feel that pain pretty well. So it's cases like these where investing in developer experience really matters, and hopefully I can convince you of that as we proceed. But that's me and that's my name. So first of all, let's just take a moment to recap how we got here. Software development in general is being democratized. There are far more people writing software today than there were just 5 years ago. Just take a look around yourself. Just take a look around this room, right? Like there's people from all walks of life, from many countries. We had a great diversity scholarship program which allowed a lot of participants to fly out here, which was awesome. And that trend is actually apparent as you sort of look at apps and as you look at people who are building software across the world. And it's gotten that way for multiple reasons. Number one, there has been a phenomenal shift and growth in computing. If you actually look at the previous generation's dominant computing platform, PCs, it took them about 2 decades to get to 500 million users. It took mobile phones less than 4 years or 5 years to get to 1 billion devices. And that growth continues today. Like by now, there's about 3 to 4 times as many mobile phones as there are PCs. This probably is not news to most of the people out here. Most of you have actually seen this graph before in some shape or form. But the reason why I'm actually here talking about this graph is because there's just a profound shift that's happening in terms of the growth of mobile apps, and it's not showing any signs of slowing down. You can go to countries today where you can buy a pretty good mobile phone for less than $100. And it actually is a pretty good device. You can get most of your things done on that. And that has been the only computing experience that almost 1 billion people have had. Like there are people who've never ever used PCs, don't have email addresses, but the only thing that they've had is a mobile phone. And that's actually a big factor in why there are more app developers, because there's actually more people using computing devices. Not just that, but we as an industry have also done a pretty good job of lowering the bar for what it takes to become a software developer. So if you consider a few things, number one, education. Back when I was studying computer science, you pretty much had to have a 4-year degree or an equivalent to have a meaningful career in computers. And most of the interesting course material was actually taught only in colleges and universities. You could get some technical education here and there, but it wasn't really well fleshed out. If you look at things today, things like Udacity, things like Coursera, the open courseware that you have available from MIT, there's a bunch of things available from Stanford. You can get most of the great content available to you for free or at very low cost. Just for us in Google, we've actually partnered with a bunch of training institutes in India to have a lot of developers go through a Android Nano degree in partnership with Udacity and a few other companies in India. And we've seen a lot of great success. And it's what this means is like more and more developers are actually coming out and building great apps, and they're being trained to be mobile app developers. Not just that, but the tools of trade are now free or really cheap. How many of you have worked with Visual Studio before in their past? All right, quite a few, right? You probably remember you had to pay hundreds of dollars to actually get a license for Visual Studio, probably cheaper if you're a student or something. And if you actually had to deploy your apps, deploy any services, you had to probably build your own services and data centers. And if you needed any other custom software, you actually had to pay more for it. Now, if you look at things like Xcode or Android Studio, they're basically free, or they cost less than $20 or something like that. And that's actually profoundly important because it actually enables more people to tinker around with software, and they don't need to invest a lot of money in just like trying to prototype their ideas, and that's awesome. Not just that, but there's a lot of great frameworks and building blocks that apps use to build great experiences. And those are basically available for free right now. You can go all the way from cloud services, where Amazon Web Services and Google Cloud and Microsoft Azure and all these other things. You can basically launch a free service today, and as long as your traffic doesn't exceed a certain amount of volume. So you get like world-class data center and server support for free. You can build almost half of your app for free. There's like amazing app development frameworks like React Native or Firebase or Fabric by Twitter and a few more. And you get a lot of the things that you would have needed to do to build an app basically built out for free. And that's spurring more and more app development as we go forward. In general, I think with mobile, open source has also truly come into its own and has really hit a good level of maturity. If you look at GitHub today, it's a very, very vibrant ecosystem. People are forking repositories all the time. People are sharing things at a far greater pace than they were sharing before. And that's actually led to more innovations in software and more people creating good experiences. Just to quote an example, Google released a machine learning library called TensorFlow about a year ago on GitHub. And in just a year, it's been forked more than any other library out there. And this is something which is like cutting edge neural networks, machine learning, image processing, those kind of things. And it's now being used pretty widely all over the world. So naturally, as you have better tools and free or cheap infrastructure and open source and great education and things like that, you see that the number of apps is actually going quite high up. There are way more apps being created today than there were a few years ago. It's important to note that the iPhone was launched about 8 to 9 years ago, and less than 7 years ago, there was no apps. There was no such thing as mobile apps. From that point until today, we have close to a few million mobile apps. So just think about the explosion that has happened, right, in terms of how many apps are out there. So things so far seem great, right? Why am I here talking about problems? And we'll get to that in a bit. Not just that, there are now multiple companies who've built successful businesses, and they started only as mobile apps. Like the companies that you see behind me, all of them actually began as mobile apps, and they're probably still just mobile apps. Like I don't think you've used any of them as anything other than a mobile app for the most part. If you just take the valuations of these companies, I think most of them are still private. If you just take the valuations of these companies and you add them up, they would be in the top 50 in terms of GDP by revenue of countries, right? Like, so think about just how big and phenomenal this thing has been from a revenue growth perspective. When you have that much money flowing through your apps and through your services, quality certainly starts becoming really important, because any loss in revenue is any loss in usability or stability means a drop in revenue, and which means people get very, very unhappy really quickly. So as these industries have matured, you now start to see people paying more attention to quality and testing and all those kind of things on mobile app software. So we did an analysis earlier this year. We took a bunch of reviews and data and crashes that were being sent to the Google Play Store. We did a bit of sentiment analysis by actually parsing the review text. And we also looked at some historical trends and data for crashes, as well as why people rate things a certain way. So the pie chart that you see behind me is actually the 1-star, is the reasons for why people give 1-star rating to apps on the Play Store. And the overwhelming reason for why people get such low ratings for their apps is actually stability issues. Somebody saw a crash. Like, you tried to use an app, it crashed, you got angry, you left a 1-star review, and you tried to express your frustration that way. For people here who are actually working in software engineering and who are practitioners of software engineering and testing and such, the answer is pretty obvious to you, right? Like, the reason why somebody crashed was because they actually didn't test properly. But and most of the app developers also kind of probably know it, but yet you have so many apps out there which actually have this like proliferation of crashes and stability issues and such like that. Even if you look at mobile apps in general, in the Apple App Store or the Android Play Store, you see like this a small number of really great apps, but then there's this long tail of apps that basically get downloaded maybe 10, 15, 20 times and nobody else uses them afterwards, right? Like, so it's a clear sign that the quality tapers off really quickly, and we aren't really doing a good job of helping bring up the level of that quality. One of the reasons why it's so hard, and I think you probably saw one of the charts in Manasi's keynote yesterday, is there's this compounded complexity when it comes to mobile app software. Just thinking about mobile apps, you actually have about 2,000 to 3,000 different device manufacturers and different hardware units and hardware form factors and such. If you kind of take the summation of all the versions of iOS, Android, and a few other operating systems, you get about 100 different OS variants you need to test on at any given point of time. There are anywhere between 700 to 800 global carriers that people actually connect to the internet on, not to mention different cloud providers, different network topologies, and things like that. So if you actually want to really do a good job of testing across all of these, like, you're looking at a insanely high number of permutations and combinations that you actually have to work with. And as a result, it actually becomes a big daunting challenge for you to build a really high quality app, especially if you're like a 2 or 3 person startup and you're just getting off the ground, and you now have to like think about this entire giant complex matrix. It's probably easy for companies like Google, where we have a lot of engineers invested in solving these problems, or other companies like Facebook, or even like banks and other things. But imagine if you're just an up and coming company, you're a few students in India or Indonesia or somewhere, and you have a great idea and you're trying to get it out, and now suddenly you have to deal with this giant set of permutations and combinations that you have to deal with. So what we found is, if the reason why actually people get into these problems is because while we've done a really good job of making it easy for people to write great apps, we are not quite there yet as an industry when it comes to helping people test apps better. And I think if you look at the user experience of our testing tools, if you look at a developer experience of what it takes to write apps and build good, well-tested software, there's a lot of rough edges, and we're actually we need to do a better job of addressing that collectively as a group. So I'm going to try and talk about a few examples of what we've done at Google to sort of address these things. The things that I'm going to talk about are actually products that you can go and use today. And we have more announcements to come in the upcoming months as well. So this is by no means a complete list. There is a a huge universe similar to the one that I'm going to talk about that gets used internally at Google as well, and it's a continuously evolving space. There's also a lot of great innovations and solutions that happen outside Google in other companies as well, and I'm going to try and talk about things that I'm more familiar with myself, that I personally work on, in a hope that we can actually inspire you and help you. So going back to this whole permutations and combinations of devices and complexity with all the hardware fragmentation, as well as all the topology and other things. So we realized that we want to help all of our app developers make a living. We want to help them build better software. We want their apps to not crash. And we realized how hard it is. Like, we actually did a lot of user studies, and we even have our own examples internally where people just want to test their app on a bunch of devices, and they don't really care about like buying devices and setting them up and maintaining them. Nobody has the time to do that. Like, especially if you're a small team, like it takes a lot of your time just to do that. What people want is a simple, easy-to-use cloud service. If you're not really doing maintenance of your own data centers and your own services and backends and things like that, then you probably should need to do it for your mobile apps as well. So earlier this year, we announced something called as a Firebase test lab. And we've been working on it for a few years. We also acquired a company called App Purify along the way, and they joined forces with us. And so we've launched this service, which there's about a few thousand devices in our data centers. And you as an app developer can actually rent them, and you can run your tests on them. We've paid a lot of attention to user experience here, and we try really hard to meet you, the app developer, wherever you are. If you use Android Studio to build your Android apps, we actually have the functionality and plugins baked into Android Studio, so you can actually, while you're writing your tests, you can actually just run them on our lab and get results back right away. We have a good command line library where you can actually use it for your own local runs and local debugging, where it'll automatically take your tests, ship it to our lab, run them, bring back results to you. We also have plugins that work with all the popular continuous integration systems like Jenkins and Travis, so that companies who want to set up their own continuous integration can do that. And we actually do have paying customers like American Express and others who are actually doing that. There's supposed to be an animation there, but anyway, imagine that there's an animation of a robot. I think the slide got kind of messed up. What we realized quickly was there's still a gap in maturity when it comes to testing. Most of the, simply providing a lab is not enough, because that assumes that app developers have actually done their job of writing tests, and they've actually done a job of thinking about testing to begin with. But most companies and apps are actually just starting up, and they don't really have the ability to, or they don't really have the time really to actually go in and do testing ahead of time. So people want something quickly, and people want to get a quick view of quality of their app. So what we did was we actually took the concept of monkey runners, which is like a random key press on your app, and we turned it into a more predictable sort of crawling mechanism. So we built this robot which actually crawls your app automatically, and it goes through all the UIs in your app. It has a bunch of intelligence baked in, and it can do things like it knows when it's seeing a OK or cancel button, or it knows things like you're about to encounter a login screen, so it can kind of try to bypass that. But the goal is we want to try and exercise as much of our app as possible in the hopes of getting it to crash. So most of the device-specific bugs that happen are actually crashes anyway. So we try to sort of give you that data as quickly as possible without requiring much effort from you. So it's a very simple one-click thing for app developers. You go to firebase.google.com, you upload an APK, and in a few minutes you get a good analysis done over a wide variety of devices that will tell you where your app has been crashing or performing badly or things like that. We quickly realized that once app developers actually start writing tests, start using a robot, and they start finding crashes, they're like, that's great. Like, I know my app crashes now, and I would like to prevent it going forward. Like, I want to do a better job of not having my app crash going forward. So they want to write tests. but it's kind of a daunting thing, and they don't quite know how to get started. There's already great documentation out there, like Stack Overflow is really helpful. The Espresso community is pretty vibrant, and so are other communities as well. But still, like if you just want something quickly done, you just don't have the time to invest a few hours or a few days sort of setting things up and studying things, etc. So what we did was we partnered really closely with the Android Studio team, and we launched something called as the Espresso Test Recorder. It's actually available today in Android Studio, so if you download the Android Studio, you can actually try it today on your phone, on your laptop. The way it works is you simply take your Android phone, you hook it up to Android Studio, and you do a bunch of actions, and we'll generate Espresso test code for you. That's it. Like you don't have to set up frameworks. It's all baked in. And these are actually working functional tests. And since it's just Espresso test code, you can actually do your own assertions. You can change things. You can add more assertions. You can modify tests. You can copy that test and write like 10 different tests. It's all up to you. You're just given with working test code. And this has actually been a big hit with app developers. We've had a lot of tests and great feedback already, and it only kind of became generally available a month or so ago. So the uptake has been pretty exciting. So we've had about 1 million plus tests already written and run on the Firebase test lab, which I'm really happy about. This is a quote from Jet.com, one of our large partners. We actually had them present with us at one of our conferences in Berlin last week, and they basically got rid of their own lab, and they're just now using Firebase Test Lab. And I think it's good to see positive feedback from our customers and getting good validation for the work that we've been doing here. So what we realized that was it's great. Like we actually got people to care a bit more about testing. We've given them tools. We've tried to be in their workflows. We've tried to help them sort of along a path. Like we've tried to build a well-lit, guided path for them to do testing for their apps. But it's still not enough. Like people still don't really discover Firebase as much. Like they don't really think of it when they want to sort of think about testing. It's still not in people's workflow as much. So one of the things that we've been trying to do is actually really help app developers get ahead of this testing curve as much as possible. So we also worked really closely with the Google Play team. So one of the things that every app developer does is they actually want to, once they write their app and once they think it's good enough, they want to publish their app, because that's the only way they're going to get their friends and family to play with it first, and hopefully the word of mouth will get out and their app will become popular and they'll be billionaires in a few years. But you first need to publish your app. And since we have a very sort of centralized mechanism for doing that, we actually work with the Play Store team where while you're publishing your app, you can just check a box saying that I would like a free robot run. No action required, nothing extra that you need to do. And we actually give you that for free. And what we do is we give you something called as a pre-launch report, where you as an app developer, even if you don't know anything about testing, you can still publish your app, and and when you publish your app to the alpha or beta channel, in a few hours, you'll actually get a pretty detailed report. Actually, in a few minutes, you'll get a pretty detailed report about what's happening with your app. So, and we actually run it on a wide range of devices of Android phones, so that we know that these devices cover like most of the crashes and most of the other kind of issues. So we know that by just running through that, your app will actually have been tested without you having to do much. So we give you information about crashes. So we'll tell you which devices your app is crashing on versus which devices it's not. We'll, of course, give you stack traces and logs of whatever we have on our devices so that you can debug those crashes. A lot of the device-specific bugs also happen because of internationalization, and they happen because of screen densities and layouts and things like that. So we'll also try and give you a auto-generated list of screenshots where you can actually find layout issues. This is actually a real example where because of German and Italian translations, the app was really not working. They had a bunch of text hidden, and the developers were able to actually catch it and fix it. And this happened only on Galaxy Note devices for some reason. We also do a deep security scan of your app. So malware on mobile apps is a pervasive problem, mostly because oftentimes app developers use libraries that were built by other folks, and those libraries might not be the most trustworthy ones. So accidentally, you might be incorporating malware into your apps without you wanting to do that. So we use the same security analysis that Google uses for its own platforms, and we do that for your apps on the Play Store, and we'll actually flag you a bunch of security issues, whether you are doing things in an unsafe way or whether you're using things that have known malware signatures. We'll actually flag you and we'll let you know about that as quickly as possible. So we've had pretty good success with just this, right? The whole reason why we want to do this is because we want to really bring up the quality and the stability of the entire ecosystem. That's why we're investing so much money and time and effort into this. And the early results are very promising. In just about 6 months since we launched, we've actually seen 20% fewer crashes for apps that actually use the Play Launch Report. So if we take two apps, one of them doesn't use the pre-launch report, the other one does. The ones who do see 20% less crashes. It's still a bit of a confirmation bias right now because the apps who tend to do it are also ones who do really care a bit more about testing. But over time, we're seeing these numbers stabilize. So hopefully, these patterns will hold. The other stat which was really promising and encouraging for us is, and this is how we actually know that app developers are really taking advantage of the Play pre-launch report, is if you had a release and you released it to the alpha or beta channel and we sent you an email saying that, hey, look, you guys had crashes and your app's not performing well on these devices. We see that 60% of those crashes are actually fixed in the subsequent release by the developer. So you release something to the alpha beta channel, you get a report, and you have fixed it before it's widely available to everyone out there. That's the exact desired outcome that we want. And I think our goal is to try and push that number as high as possible, as close to 100% hopefully as possible. So far we've seen great uptake here and really happy about that. I want to switch gears just a little bit to crash reporting. I know it's not exactly in the realm of testing per se, but we think that by working closely with app developers and by engaging them through the entire app's lifecycle, we can actually have a positive impact on software quality and app quality. And we are firm believers in helping app developers closing the loop. So our goal is to make sure that these things work seamlessly as much as possible. So we took the same principles of simplicity and user experience, and we brought them to crash reporting as well. Because face it, even if you've done a good job of testing and you've used the test lab to its full potential and you've written tests, there's probably going to be some arcane issues that you're going to only find because you didn't think of them or you couldn't anticipate the environment changes. So we as a part of the Firebase SDK, we actually include crash reporting. Our goal is to give you not just data, but we want to give you data that you can actually take action on and help fix bugs as quickly as possible. And then hopefully you'll use our test lab to actually write tests and not have those bugs in the future. So it's a very easy setup. You integrate our SDK, you do a one-line initialization, and that's it, you're done. Once you release your app, you're going to start seeing crashes right away. And that's great because people want data as quickly as possible. They don't really want to do complicated setups for something simple as crash reporting. This works across both Android and iOS, so we're kind of trying to engage all app developers here. We've used Google's proprietary algorithms and expertise in trying to figure out which two crashes are similar, and we actually use that same technique to cluster crashes and crash data and make it available to app developers. So Even though the stack traces might be slightly different, but they are the same root cause, you'll find them in the same clusters. So you don't have to waste time going through like 5 stack traces and realize that, oh wait, they were basically the same issue. We try to do that for you as much as possible. We've been using this infrastructure internally for quite a few years, and I'm really happy that we were able to bring it out to the wider developer community as well. We've invested pretty heavily in user experience. We try to keep the UI as clean and as simple as possible. Again, developer experience really matters. Nobody really gets out of bed wanting to look at their crashes, but at least when they're looking at it, they should not, they should have a good experience, and like it should be easy to use, etc. We try to also highlight the big picture of what's causing the crashes and where exactly these crashes are happening. So we'll try and isolate by phone versions. We'll try and isolate by operating system versions, other environment issues, just so that you can quickly get to the root causes as much as possible. Not only that, we've actually and this is where one of our innovations really comes into fore, is we actually work really closely with usage analytics so that you can actually get some repro steps leading up to a crash. Because how many of you have debugged a crash report before, but you didn't know how it actually got there? Few hands, okay. It's really painful. I mean, really, sometimes you don't know what the user actually did. So what we've done is every time we actually see a crash, we also take the entire buffer of what the user had done in terms of the analytics, because people who use Google Analytics also use the Firebase SDK as well. So we can actually log those same events with the crash. So you actually know what actions the user had taken leading up to a crash. So we know they opened a certain activity, they swiped somewhere, they clicked on some elements, and we can cluster that data along with your crash report. So you can reproduce and debug these things better. Again, as I mentioned, we try and really bring out as many environment variables as we can, so that you know if there are any particular correlations you need to take particular things into account. Does this crash happen only when I'm charging versus when I'm not charging? Does it happen on Wi-Fi, or does it happen on mobile networks? Like, giving you that data really helps you fix these crashes really quickly. And by default, we have a pretty powerful crash logging mechanism, but we also have custom logging. So you as an app developer can log additional things along with your crashes, so that you have more breadcrumbs and data to play with while you're debugging crashes. Just another screenshot of our logs. I'm just not going to talk more about that. This is one thing that I would really want to emphasize on. So what you see behind me is actually a graph of usage analytics, like how much money your app has made over the past few weeks, et cetera, et cetera. But what we've done is we've actually married the crash data to your analytics data. So people here who've been testing, and you filed a bug because you saw a crash, and how hard was it to convince your PM that this was actually a bad bug that they should fix? Like, because should it be a P2, should it be a P3, should it be a P1? Like, what should it be? And many people have this experience where they just don't know the impact of a crash. Like, is it something that it's a crash but nobody really cares about it, or it's a crash that's going to cause a rapid decline in your app usage and your retention and those kind of things. So by trying to highlight that data, by trying to get that data out there to app developers, we think we can help them prioritize bugs better, so that they know which crashes they should be focusing on, because they know which crashes are now causing big drop in engagement, big drop in retention, app installs, etc. And we have all that data that we can neatly tie a story around it. So they can focus on solving the most bad crashes first, and then sort of go down the stack. Here's an example that people actually use, something like that, where the value of closing the loop is really important. It's you're an app developer. The people who spend money in your app are your live stream. Basically, if you lose them, you're going to lose revenue, and you're going to go out of business really quickly. And for folks like that, they now have the ability where you see a crash, you know which users saw a crash, you can actually fix the crash and then sort of send them a notification and a credit based on the fact that you were able to fix that crash. And because it's all sort of built around a usage analytics framework, you're all working with the same, it's the same data set. So you don't have to go and sort of do custom analysis. It's just baked in there for you, and you can actually work with those audiences and those filters that are automatically created for you. So by making it really easy to close the loop, you can actually have a big impact there. So I want to spend a few minutes talking about a bit more forward-looking things, where sort of we see the trends heading forward and how collectively as a community we can work on this. So number one, I want to talk a little bit about machine learning. We are right now living in a golden age of machine learning. It's progressing so quickly and so rapidly that it's things that seemed impossible a few months ago are just very easy today. Like a year ago, nobody thought that computers could beat a human at a game of Go, which is like an ancient Chinese game. But yet, we were able to do that a few months ago. And the power of like image classification and image learning and things like that has significantly progressed in the last year. And as more and more of these things are open source and available on cloud and other things, these are just going to progress at an even more exponential clip. So my challenge to you as a community is how can we actually harness the power of machine learning and bring it to testing and software quality? Like how are we effectively teaching machines to detect things that are undesirable behavior? So if, how are we teaching machines to actually spot mistakes in your code or in the way you're developing software? Can we effectively use these machines to build assistants for you who are watching you from behind your back? They're your pair programmers. They're your code review buddies. They're your testers. And you can. How are we actually sort of building this power into our development workflows? I can guarantee you that the solution that's going to win in this particular field is going to be the one that actually gets the user experience just right, because there's a lot of interesting papers and algorithms and sort of approaches out there, but in order to really make a difference here, the user experience is going to be critical as well. So how well you actually blend all that power into your workflows and how you sort of seamlessly advance that forward is going to be actually critical to solve these things. I also think that we don't really exploit and invest more of our compilers and tool chains. We have really great ways of optimizing apps and building and deploying things, but as a software testing industry or as a software engineering practitioners, we don't really harness that power as much as we could. And I think there's a ton of innovation that we could be doing in terms of static analysis, dynamic analysis, code generation, code optimization, and more. And I would really like to see the community rise up to these kind of challenges going forward. So you probably, if you weren't sleeping through the presentation, you probably remember this graph before that I talked about at the beginning of the slide. The reason why I bring this up again is look at the difference in slope. Mobile caught everybody by surprise, including us at Google, even though we own one of the most widely used operating systems in the world. It caught us all by surprise, and the growth has just been staggering and exponential. It's now that we're sort of trying to wrap our head around the explosion of mobile and trying to, as a testing industry, we're trying to sort of come close to fixing some of these problems. We're not quite done yet. It's going to take a few more years to get there. But the last few years have been fairly painful for those of you who have worked on mobile. So I don't have a crystal ball, right? Like, I don't know what the next big thing is going to be. I don't know if it's going to be augmented reality or virtual reality, or is it going to be assistants, or is it going to be just AI in general, or is it going to be self-driving cars, or is it going to be wearables, or Internet of Things, or things I don't even know about, right? But I can guarantee you that the next slope is going to be even more sharper than this in terms of the way it will get adopted, just because a larger share of humanity is now primed for adopting new platforms. So let's not repeat the mistakes or the things that we did on mobile for whatever comes next. And that's all I have. Thank you.
Excellent. Thank you, Niranjan. And thank you for leaving plenty of time for questions, because we've got a lot of them. Which I have here. Yes. Test lab run tests on real device or simulator?
Both. You can choose either. It costs about $5 to rent a device for an hour to run your tests. It costs about $1 to rent a virtual device or an emulator for your test. So we support both.
Good to hear. Are you also working on something which helps test end-to-end client-server test apps? Are there any frameworks to do so?
That's a great question. We did think about it quite a bit in terms of our roadmap and other things. Unfortunately, that's one of those things where these are so heavily dependent on the topology and the software architecture that a particular app is going to use. So it's really hard to generalize a solution for folks, but we're looking into it.
And any questions in the room, feel free to raise hands. I'll get to you. Right after I read this question, what about tools for iOS apps? What most app developers have to support Android and iOS?
We have heard this feedback loud and clear, and all I'll say is stay tuned.
Yeah, so we actually use the Play Publisher API to upload our APKs to the store, and we noticed that with that we don't get the pre-launch check. Is there a reason that you guys?
Yeah, we're working on it right now. So because of reasons that have to deal with lawyers, we require you to check a box right now, but we are working on it.
Yes, reasons because of lawyers explains many, many things. And at any time, raise your hand if you have a question in the room. What initial setup do you recommend for a small startup that needs to start introducing automation into a project?
Wow, that's a fairly broad question.
Let's just list them all.
Yeah,
everything you need.
So, I mean, I would really, and those of you here at Google have heard me rant about this. Sorry, you have to hear this rant again. Number one, if you can unit test it. Like that's in terms of the return on investment, in terms of the amount of value you're going to get in return for the time you spent it. It beats anything else hands down. Even today, like the state of unit testing on mobile is nowhere as good as I would like it to be. Doesn't matter if it's inside Google or outside Google. So if you were an app developer and if you had to spend time, I would say if all you did was just unit tested really well, and if you wrote really well tested code with like good unit tests, and you used some form of a robot or a monkey runner to sort of get some device coverage, you're probably going to get a decent amount of coverage for a very cheap amount of investment. So that would be my recommendation.
Very good. Does the lab also test for geo-specific scenarios? For e.g., is there a way to run only on devices and networks in India or Mexico?
Another piece of feedback that we've heard loud and clear, so all I'll say is stay tuned.
That seems to be a theme. A speaker yesterday mentioned his team discovered differences between emulator and real device tests. Does Firebase Test Lab run on emulators? I think we already answered that. How does pre-launch testing work? Is it automatic monkey testing, or does it include some manual testing results? How did you detect localization problem?
So it's all automatic. There's no manual element involved here. We crawl your app and we'll analyze the data. In terms of localization problems, it's right now we just give you all the screenshots, and it's the onus is on you, the app developer, to actually find those issues per se. But we are working on automating that away as much as possible as well. We have some great screen diffing infrastructure within Google that we're trying to bring it out as a part of the test lab as well.
Okay. Can you exclude certain paths like the robot takes, like making real purchases?
Not yet, but we're working on it. So the way we are letting app developers do that is by actually providing us accounts that don't lead to any disastrous effect in your system. So it could be a test account that actually doesn't, like, even if you purchase, the purchase doesn't go through. But we are working on letting you isolate parts of the crawl tree better. So think of it like a robots.txt file for your app robots.
Other words, stay tuned. Is it?
Yeah, you can just answer those questions that way.
Not this one. Can you talk about efforts to bring test labs to classrooms?
So you can use TestLab for free today. If you can get something like 5 hours of testing every day for free, and it's open to all of you. If you are in classrooms, if you are a student, you can just go to firebase.google.com and you can actually start using it for free today. So, and it's built in as a part of Android Studio, which is also free. All the material is published on the Android developer website, on Google's other website, and we are working on bringing some of the content over into Coursera and and Udacity and other things that I talked about earlier. So the tools are already available for free for you to use today, but we'll be trying to bring some of the educational content and packaging it in a more classroom-friendly way as well. But no, that's great feedback. Thank you.
Any other questions in the room? Oh, got one.
Here's a mic.
In the meantime, maybe you can answer Firebase or Sauce Labs. Which is better?
No comments.
You said that you will dump the buffer when we submitting the crash data, right?
Yeah.
So how you deal with the privacy data? Should we consider about that?
Yeah, no, that's a great question. So we do a few things. Number one, we don't have access to the data. It's you, the app developer, it's your data. So in a certain sense, it's also your responsibility to make sure that you're not accidentally logging things that include personally identifiable information. Having said that, we try and take as much care as possible to actually scrub out things that we think might be offending. So we have things that we have a system that look for patterns around credit card numbers, social security numbers, driver's license numbers, email addresses, phone numbers, etc. And we'll try and scrub them out of the logs as much as possible. So as a result, but we can't really guarantee 100% coverage there. So which is why we also, the app developers themselves need to be involved in this process.
Okay. Can Firebase figure out the memory leak on the background of the UI test? In Android Studio, we currently have to find out the leak by process ID.
So right now you can get a bunch of performance data when you run tests on the Firebase Test Lab, or even when you run them through the Play Store's pre-launch report. We don't quite yet identify memory leaks per se, but as standard refrain, we'll look into it into our roadmap. It's definitely one of those areas where we want to continue innovating going forward.
Will you ever allow plugins?
I don't know what that means, sorry. You can send me an email with more details. I can answer that offline for you. I don't know what plugins that you're referring to here.
My name is Theodore Chan. So I had a question for Firebase. You have tools for localization and geo with consideration for language, and then also bandwidth changing, or issues with variances in bandwidth and networking considerations.
So are you, is your question around libraries that you use while developing apps, or is your question around?
More for the tools you guys have for Firebase for geos and localization for going to different regions and languages.
But are you asking it as a person who's authoring tests, or as a person who's building apps, or?
Both for testing and then for development. If we have an app that's for North America in English, and we're adding Spanish and moving to other geos, what kind of tools does Firebase have some tools currently?
No.
Okay.
We don't. So we do things like it's most of the Firebase infrastructure is fairly locale agnostic. You generally don't the tools themselves are localized in all the languages and available in multiple different languages and locales, but we don't do anything specifically to actually support that. In most cases, those are actually handled by your operating system libraries anyway. On Android, you have your layouts that really mostly handle that, and on iOS, you have your resource files that do that anyway. So We generally don't have a common solution there yet.
The ever-present plea to improve the Android emulator.
So I want to give a huge round of kudos to the Android team. If you look at the emulator over the past year, it has actually improved significantly, and the Android team is investing a ton of resources in doing that. So yes, it's definitely happening. It's already improved quite a lot, and it's going to improve a lot more. If you have specific feedback about the emulator, please come talk to me after this. I'm happy to channel it to the Android team. But I know they're working on it feverishly. Like, this is one of their top priorities.
Can we get the pre-launch report for every version submitted to the Play Store?
So we can't go back in history and give you that for all the older versions, just because we have to seek your consent before doing that. Lawyers get in the way. But you can get it for all future versions. So.
How about stress testing? Let me guess, stay tuned.
So it's actually, you can do that today. It's on you to write those tests to actually do stress testing. I mean, you can write tests and that run for an hour and stress out a bunch of things in your app and get all the data back. You can do it today, but we don't provide anything specific. You have to write those tests.
Available today. Very good. The differences from Crashlytics.
So first of all, I'm a big fan of Crashlytics. They're an amazing team. They've really innovated very heavily in the sphere of developer experience, and I must give them all the props and credits. The fundamental difference, I think, that I see is, like, we are very well integrated into the Firebase suite of things. So if you are an app that actually is using Firebase for other things, such as using backend as a service, or using our notification services, or our app distribution mechanisms or analytics, then you probably want to use Firebase Analytics. Crashlytics is pretty powerful too. I do think that our clustering is probably slightly better, but they have amazing tools and experience. Their setup experience is also really good. So I mean, if you're using Firebase, and using Firebase Crash makes more sense. But we have a lot of people who also continue to use Crashlytics side by side, and that's fine by us.
I guess skipping one, staying with crash reporting. How about criticism?
Same thing. I think the Crashlytics right now has a far higher market share than criticism. But I mean, yeah, it's a crash reporting service. You should use one that makes most sense for you from your developer workflow. How much do you care about being able to tie crash data to analytics data and to other things? And if you want that, then use Firebase. If you want the other features, use criticism. Really, like, it's they're mostly at feature parity in terms of just the bare bones crash features. Like, you get a crash, the crash gets sent up, it gets clustered and analyzed for you. So the basic features are the same.
Oh, and I didn't mean to skip the one that was before that one. So if there's a way to get it back, or if somebody wants to ask it in the room. Oh, is it here? Okay. Can we find out the list of tests being run in pre-launch test are all selected for all types of apps?
So we don't actually run, like, there's no list of tests that we run, right? Like, there's a, we crawl your app and we'll try to uncover things along the way. Our crawler doesn't really know anything about your app, so we don't really have, like, a pre-canned set of tests that we want to run on your app. And then we try to report data around crashes, security issues, layout issues, etc. So you can definitely see all apps get the same treatment, really. So
What platforms are supported, and how it's avoid false positive?
So I'm assuming this refers to the test lab crawlers, this particular question. So it supports Android versions going back a few releases up until KitKat, I believe, maybe even a couple releases below that. We support different form factors. We support different OS variants, hardware manufacturers, etc. In terms of avoiding false positives, really, if we see a crash, we report that crash. So there's, like, there's usually, in case of crashes especially, there's no false positives generally. Like we know you kind of crashed because we see the crash.
Hi, I'm Usman from BlaBlaCar. I had a question about the crawler again, the app crawler. How well does it perform on different kinds of apps, such as games that have no real menus? And
So
how
game-
smart? Oh, sorry.
Games has been a very challenging. Sorry, I didn't mean to interrupt you. My bad. Games has been a very challenging thing for us, mostly because the crawler has no way of knowing the gameplay mechanics. So we are trying to figure out how we can work with game developers here. So a lot of game developers actually have demo modes or sort of like pre-canned modes that you can go through games that they use for testing their graphics or their physics engines or things like that. So if we need to make sure that our crawlers can be fine-tuned towards that a bit more, but it's a pretty hard problem. It's a work in progress. Like we don't have anything to announce immediately on that. But that's a great question. It's pretty hard to come up with an answer for that one.
Thanks. And the second part was, can it be made a bit more intelligent by just seeding it or allowing app developers to seed it with some actions that are coming from real users or from themselves?
Yeah, so we are working on that, yes.
Thanks.
Performance and security. How
So
about it?
I think I answered the performance question earlier. It's up to you. You can always write a test that stresses the action multiple times on your app and get performance data for your app. In terms of security, we can give you, like you get the security report through the robot run right now and the pre-launch report. But if you can always do more security tests if you really want within your app. You have the power of writing Espresso or Robotium or UI Automator tests and doing that yourself as well.
Software development being more accessible, free education tools, blocks. What is your perspective on the impact on quality software?
So
Testing for accessibility, I suppose.
yeah, I think in general, I think the quality hasn't really kept pace with the growth, and that's pretty evident. And I think you saw the stats earlier in my slides today, where we actually did an analysis of the one-star review apps with one-star reviews, and it was really eye-opening when we did that analysis, where the long tail actually has like pretty high amount of crashes and generally quality and stability issues. So yes, it's a problem, and hopefully we presented a couple of our efforts that are helping solve this, but we are no way close to done. Like I think it's a long road ahead for all of us.
How about Xamarin? Do we work with that?
So you can definitely deploy the apps that have been built using Xamarin on the test lab. Also, I think Xamarin now has their own test lab, I believe, if I'm not mistaken. They were acquired by Microsoft, and they have their own test lab. Or maybe I'm missing things, but they also have something within their developer environment as well. But you can, like, if you have an Android app that was built using Xamarin, you can actually run it on Firebase test lab today.
Hi, Caden from Busy. Mobile apps that usually deal with persistent storage have to test data migrations on updates, and I was wondering if the pre-launch report tests from the previous version to the latest version being installed on top of that, or if it's just a fresh install.
That's a great question. It unfortunately, because of security reasons, we have to do a fresh install. So what we do is after every test run, we actually wipe the device clean, we reinstall the OS image, bring the device back to a previously known good state, and then it's a fresh install. The security challenges make it really hard to deal with that a bit more. But we are hoping cases like those, you can actually do it through your own custom tests, where you could actually install one version and then another version by writing custom tests.
Do you ever think Firebase will ever allow us to run unit tests on real devices? Similar to how you can run JavaScript and tests in browsers.
So I'll just do a little nitpick here. In technically unit tests, you should not really be caring too much about devices. Unit tests are just testing a small piece of code in isolation. On Android, I'm a big fan of Roboelectric, you should just use Roboelectric as much as possible. It's amazing. It's the best thing ever. So having said that, you can run any test on a test device. Like we support JUnit, we support Espresso and other things. So yeah, you could have a JUnit test running on real devices today.
How about automated accessibility testing?
It's definitely in our roadmap. In the pre-launch report, we want to sort of try and highlight some of the things as well. So stay tuned, I guess.
Do you have any data correlating the quality of developer experience to the quality of applications built?
Unfortunately, we have the correlation on the other side where by engaging with developers as much as possible in their workflows and by really improving the experience, we see a positive impact on quality, but we don't have data that goes the other way at the moment.
Do you need to provide credentials to access the app to test?
No, you don't need to, but if you can, then your app, we can do more with your app.
How about penetration testing?
We don't do a whole lot of penetration testing. We do a whole bunch of basic security crawls looking for things like you're using a HTTP stack that we know has bugs in it, or you're doing data marshalling in an unsafe way that we can detect by looking at your app's signatures, etc. But beyond that, we don't. A lot of the other penetration testing actually requires manual intervention and input, and we're hoping that over time we can use machine learning and other things to help with that. I think last question, or we're kind of out of time, or
They keep coming in. You're stimulating even more questions.
Right.
But yeah, we'll take say 2 more. When Espresso will be more flexible to write tests to switch and get full access of the device and its pre-installed apps?
that's a great question. I know the Espresso team is working on it and it's on their roadmap. I just don't know where they are with respect to the release timelines, but it's something definitely that the Espresso team is working on pretty heavily.
All right. And finally, if my app requires interaction with other nearby devices with the same app installed, can I use this framework to test my watch app,
Unfortunately,
for
not.
example?
Unfortunately, not yet. Just because when you have about a few hundred devices shoved into a same rack, we have extreme amount of challenges with Wi-Fi interference, with other sort of isolating radio signals, etc. So adding Bluetooth to that mix, for example, would make things super hard for us. So at this point, unfortunately, we don't have a good hardware solution for you to do that yet.
Okay, excellent. Yes, I think I will spare. Oh, is there one more in the? All right, one more in-room question.
Are you leveraging a WebDriver for your UI interaction or a proprietary approach?
So we use Espresso basically for all our UI interaction. For native apps, we don't really use WebDriver, and Espresso is open source, and it uses the basically the open API within Android for accessibility API within Android for traversing the UI. So we use open source technology.
Thank you, Niranjan, for taking the onslaught of questions.
Thank you.